Okay, so this is first in a series of videos that we're going to be making on 3D Studio Max, thinking about spatial design, and in particular starting with some content for our design product. In this case, we're designing an enclosure space for a dinosaur. So we want to actually start with a dinosaur itself. So I already have a few downloaded, and I'm simply going to go through File, Import, and I'm going to navigate to the FBX or film box version of a Tyrannosaurus Rex. And that's going to be dropped in place. So there are a couple of things that you see with this. There's obviously the mesh, and then you can see hints here and there of the bone structure underneath that I could use to animate. That's going to be way more advanced than we're going to get in this set of topics. So as I move things around, I'm just going to kind of leave those bones behind. Eventually I might delete them in a later video, but we're just going to kind of ignore those and just primarily pay attention to this outer mesh that forms the T-Rex. So first thing is I always want to work at a 1-to-1 scale. So I want to bring in a box that is going to be closer to the actual size of a dinosaur, and then I can scale this to match. So to do that, I'm going to go to the Create tab, Box, and I'm going to go ahead and lay down the footprint of a box. And once that was done by a left click and drag, and then a left click and release. So right now this box is 2 feet by 1 foot by 1 foot 5 and change, okay? And I know what I really want in particular is this T-Rex to be about 20 feet tall. So I'm just going to go into my parameters, type in 20 feet, and get that height. So now I have something to scale the T-Rex to. So moving around really quick in 3ds Max, I always want a wheel mouse with almost every 3D program as a minimum. I'm going to use the wheel to zoom in and zoom out. And if you'll notice, like if I want to zoom in on the foot of the T-Rex, I can hold my cursor directly over that location and it will zoom me in exactly on that, the T-Rex toenail. Okay, so what I'm holding over is what is going to be zoomed in on specifically. Really important with 3ds Max. Next, I can hold the wheel down and that's going to allow me to pan, and I can Alt and hold the wheel down and that's going to allow me to orbit. So that's really sort of a standard mode of operation in most 3D softwares, is that pan, zoom, and there's usually sort of a secret handshake. It's different for each program about how to orbit around something. And it's typically going to orbit around whatever is selected. So for right now, I actually want to go ahead and deselect my box and select my T-Rex. And I'm going to use the scale tool to increase the size of that T-Rex to roughly match this 20 feet. So that's 3 really common tools in Max. Right here, top center on the menu, move, rotate, and scale. So I'm going to select the scale button. And I'm presented with a widget that I can scale by. And so I can use the widget in different ways. If I only want to scale the object vertically, I can select just the Z widget and stretch it out. Not really what I'm looking for, so I will Control Z, undo that. If I go to the middle, it's going to scale everything uniformly by the axis. And most of the time, that's what I'm doing inside of a 3D workspace. Again, I'm not going to worry a whole lot about the accuracy. I want something that's approximately 20 feet. I can go just a shade bigger, get something about like that. So I want that size to start to come together correctly, so that I can, simply begin thinking about how we would design an enclosure around something at this size. And again, in 3D, I'm always working at 1-to-1. I don't want to work and think about, well, let's go ahead and scale the T-Rex down to a 1/4 inch size and work at a 1/4 inch scale. I always want to be working 1-to-1. So that way things will transfer to different programs correctly. And really, I'm only worried about scale when I'm doing output. Printing, 3D printing, fabrication, those kind of things are where scale becomes really important. So speaking of which, let's go ahead and set this up for 3D printing at a really standard level. So this is, if I'm doing some of my first 3D printing ever, this is the method that I would use. There are more advanced methods, but they begin to get a little bit complicated. And right now, I just want to do the basics. Let's get this 3D printed. So I would select my object, and I'm going to come in and do a File, Export, Export, and I'm going to save this. I'm just going to go ahead and write it temporarily to my desktop as an STL file. So most 3D printing systems are going to work with either STL or OBJ. Stick with stereolithography right now, STL files. Tried and true, they're going to work well. So I'm going to type this in as T-Rex-20 as my reminder that it should be 20 feet tall. And I'm going to go ahead and hit save. So I'm going to move this file, and note in 3ds Max, really quick, sorry, quick diversion. By default, selected only is checked. So if nothing is selected in your scene, nothing is going to export. Okay, so you want to make sure that you have your object that you want to select or that you want to export selected. So go ahead and hit OK to that. I'm going to be using Cura. Cura is a really good default standard that interfaces with a great number of 3D printers. In particular, I'm using a TAS5 right now, which is great. I love it. The TAS5, TAS6, they're excellent little printers. Really, really fabulous. So I'm going to go to the desktop. I'm going to go to T-Rex-20 and open. And the first thing that you're going to notice is this is clearly not a 20-foot tall T-Rex. This is about a 10-inch by 10-inch by 10-inch build volume on the TAS5, and it is definitely not 20 feet. It's definitely not at a 1-to-1, and that's because where 3D Studio Max is going to work in a default numeric scale of inches, so 0, 0, 0 is an inch, and an inch. Cura is going to actually work in millimeters. So we've already taken that what was 1, 1, and 1 as an inch, inch, and inch inside of 3ds Max, and that's been reduced down to a millimeter by a millimeter by a millimeter. So we already have some scale discrepancy things that are happening. And I know that I'm going to open up a web browser here off my screen really quick just to do the conversion. But I know to scale that this T-Rex at 20 feet tall, if I want to print it out at a 1/4 inch, should be about 2.5 inches. So I'm going to do a quick conversion factor of inches to millimeters. And if I do 2.5, that's going to give me 63.5 millimeters. And that's just a really quick way to begin understanding the scale of my object. If I want this at a 1/4 inch scale, I know my 20 feet is 2.5 inches. That would equate to 63.5 millimeters. So I can select my object inside of Cura. I can hit scale. And right here I have my Z size. So I just want to set this Z size to 63.5. That gives me, at 20 feet tall, a 2.5 inch scale model of my T-Rex. So I can start using this to build with physically as I'm trying to figure out what kind of enclosure I would do. So that is at a 1/4 inch. And again, scale is always incredibly important. Don't do these things in an arbitrary way, but know exactly what scale that we're printing out so we can maintain some consistency. So right now this is a 2-hour print. I'm going to go ahead and load our printing profile that we're using right now with our TAS5. We're printing with a polyester, which is a product called Engine. That's the filament that we're using. So I'm going to go to first expert and full settings. That's the first thing that you want to check on Cura, is make sure that we're full settings. Next, the machine, we are using a TAS5 with a 0.5 nozzle. That's going to be different for the rest of the internet watching this, but right now we're using Lulzbot TAS5 0.5 millimeter nozzle. Not a lot of definition, but it's really fast and really consistent, and that makes us happy. So now I'm going to go to Open Profile, and essentially I'm going to open up the Engine High Resolution Profile. And I'm going to say Open again to that. So now all of my slicing is done based around that Engine High Resolution Profile. So to look at what's happening specifically, I'm going to go to View Mode and Layers. So I have 351 layers that are being printed. It has an infill density of 20%. I can typically, for architecture stuff, for basic models, I can drop that to 10%. It's a really good number. And I know that everything looks good in terms of the layering. All of this stuff is going to work great up to right about here. Gravity works. When the print head comes to lay down filament at this location without anything underneath it, that is just going to turn into a pile of spaghetti. And it gets worse. As I come out here, the little T-Rex claws, also a pile of spaghetti and a pile of spaghetti. So you can look at this blue line. That's the tool path. The print head is going to move to this location and put out filament. There's nothing underneath that, so it's just going to fall to the base plate or get clogged up in this location over here and ruin everything for me. So I need to do a couple of things. In particular, I need to go ahead and add in some supports. So to add in the supports, I am simply going to go to my support type, and I'm going to say touching the build plate. So now everything that has an overhang that is directly below the build plate is going to get a support. Now these things are kind of brutal. They're really difficult to remove. So there are more advanced methods of doing supports, but this is where to start. This is going to start with a really simple automated method that's going to get you some really basic results before you move on to more advanced techniques. But it's like I said, this removing some of the support material like in here or around the little T-Rex claws, it's going to be tricky. Things are probably going to break here and there, but it is the perfect starting point in terms of getting a really good solid 3D model out of the computer. Adds a little bit of time, not a lot. The final part of the process before sending it to the 3D printer is to simply click Save G-Code. And this is going to give me an exact tool path. So I would just simply hit save on that and transfer that over to the SD cards that are attached to our 3D printers. And then it's simply making sure that you're setting, before you start the print, setting the base plate and the tooltip temperatures prior to starting the print itself. So double check what our what's recommended, set the base plate temperature, set the nozzle temperature, and then once those things are actually to temperature, which usually only takes a minute or two, start the print from the G-code.